Good afternoon. I'm Sim with AEBC, and I'd like to welcome you today to today's Tab Talk webinar and thank our sponsor, Evergreen Telemetry, for supporting this session. I'd like to cover a few items before we get started. Presenters will be holding questions until the end of presentation, but we encourage you to submit them at any time using the Q&A button. If you happen to be experiencing technical problems during the webinar, please use the chat function to inform the panelists, and our producer will assist you. This presentation is being recorded and will be available for viewing in 1 week. In terms of continuing education credits, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. And finally, if you are a certified TBE TBT, your CEUs for attending any webinar in this series will be automatically uploaded to your respective portal after the webinar. Today's webinar is the role of TAP contractors in the commissioning process with Justin Lewis of Pangea Consulting Group. A little about Justin before we move in. Welcome, Justin. Justin Lewis is an AABC TBE and CXA with more than 24 years experience in the construction industry and the owner of Pangea Consulting Group. With a passion for TAP and commissioning, he is dedicated to the continued improvement of the construction process. Through years of experience and lessons learned, Justin offers insight and strategies for more effective project management. So without further ado, I'd like to hand it over to Justin to kick us off.
Thank you, Sim. Thank you very much. Good morning, everyone, and thanks for joining this session. I'd like to thank the WABC for this opportunity. Sim and her team worked really hard putting these together, and they always do a good job. I'd also like to thank Evergreen Telemetry for sponsoring this and their continued support of our industry. Today, we're going to be talking about the TAB's role throughout all phases of the project. Specifically, I hope to highlight the opportunity for TAB to add value in each phase of a project. So let's start by identifying the phases of the project. First of all, we have the design phase or the pre-design phase. This is the conceptual stage of the project when we have when things are really starting to kick off. Then we have the design phase. This is when the project starts to take shape. Concepts are turned into hard designs. We have the construction phase. Buildings begins, equipment is installed, and things are started up, TAB activities are going on. We have the acceptance phase. The finishes are in place, the systems are fine-tuned for proper operation. This is typically where commissioning has their biggest role. And finally, we have the post-occupancy phase. This is when the end user has taken control and warranty begins. These are the standard phases of the project. There will be deviations on certain projects, specifically when we're talking about retro commissioning or even upgrades to existing facilities. But for today's discussion, we're really going to follow our focus on this more common path. So we can think of a project phasing as a roadmap that outlines each stop along the way to our final destination. So let's start by looking at the design phases. The design phase includes two parts. Relative to the TAB contractor, they tend to bleed together. In this presentation, we're going to look at both, but certain scopes can occur in either or. This is typically predicated on whether this is dealing with an existing facility or a ground-up new construction. So the journey starts with pre-design, and then we move to the design phase, which we'll talk about in a minute. But let's start with the pre-design. At this point, the commissioning team, the design team, they're working with the owner to answer three basic questions. First, what do they want? What do they plan on building, and why are they building? And What are they going to use it for? Are they wanting to focus on green building? Are they looking for luxury or shooting for a modern, unique design? What's the purpose of the build? Second, what do they need? The essentials are based on the end use of the project. Are they building a clean room or an office space? Is humidity a key factor? The needs will drive the overall design. This is why we have an OPR, not an OPW. This brings us to, what do they have to work with? Now, of course, this includes financials, but I'm more specifically talking about, if this is an existing facility, are we incorporating existing equipment? Will we be utilizing an existing chilled water system, for example? Let's take a look at a project we were involved in last year. So this is an existing data floor that had been having issues for quite a while. They were having hot and cold spots in the cold aisles. They weren't able to really maintain a stable temperature throughout. The owner had an in-house commissioning team, and they were working with an engineering group on plans to remodel this to take care of the problem. They were going to replace the units, upsize them, and increase the duct size to accommodate more airflow. We'd worked with the commissioning team previously on some projects, so they asked us to come in and do a preliminary investigation, basically find out what do they have to work with. We first installed data loggers in the cold aisles to tread the temperatures for about a week. The thermostats were found to be in poor locations for accurate reference points. The system is comprised of 5 RTU systems that are 100% recirculation, no outside air. They also share a common supply plenum, and the distribution is off of that common plenum. Each unit has a dedicated return intake. So one interesting condition that we found when we started digging into the sequence and what was going on was that the units run 100% of the time. They never turn off. They run 24 hours a day. They ran at 100% speed in full cooling. And when they're satisfied, they drop down to 80% speed. There was no option for them to shut down in an occupied state. They would only shut down if their disconnect was turned off. They were put into service, or they had motorized dampers that would isolate. But this was not an automatic operation that was available for just a satisfied mode. This presented an interesting problem. So this means that if AC2's thermostat became satisfied, AC2 would ramp down to 80%, cooling would go off, and we would go into 100% recirculation mode. Now, this means that we were recirculating return air directly back into the shared supply plenum. So this resulted in hot air being supplied to cold aisles, because we had about 92 degrees return air. And that means we were discharging about 92 degrees back into the supply plenum. So the main taps that were off that main supply that were closest to that system were getting really warm air distributed. Long story short, we were able to resolve the issue by adjusting the satisfied mode speed to approximately 25% fan speed. We worked with the manufacturer's rep to get that adjusted. At that point, the back pressure from the other systems essentially deadheaded the airflow. They ended up not needing to replace the units. This was a sequence issue, not an equipment issue. So this saved them a lot of money. But let me highlight one point. Pre-reads, preliminary investigations, they're only valuable if they're reviewed. Many times, pre-reads are seen as a box to be checked. They're often outlined in contract documents or plans or specifications when we are dealing with an existing facility. However, many times tab's not involved early enough, or in some cases, it's just skipped. We've also ran into situations where we've done pre-reads, we've submitted a report, and they were never submitted to the engineer. This is another reason to bring TAB further up the food chain to make sure that communication is strong. Understanding the existing operation and limitations of systems is critical for the design team. So this brings us to the design phase. When TAB takes an active role in the design phase, there are several opportunities for added value. Again, existing buildings have unique issues and requirements. As-built and system evaluations can bring to light limitations and many unforeseen problems. How many times have we dug into an underperforming water system on an existing system and found this? Design teams may assume ideal conditions that don't really exist. This can dramatically affect the system performance down the road. Not only is it important to identify limitations so that the design team has all of the information they need, but the construction team needs to understand and document existing conditions as well. It doesn't matter how poor of a condition the system is in, if they were not verified beforehand and documented, the construction team owns it. Why? Because everything worked until you touched it. New construction provides opportunities for added value for TAB as well. A thorough review of initial design for balanceability and the sequence of operation is critical. Even the best design can overlook key limitations, either of equipment or testing, or rely on perfect conditions. Let's look at another example I was involved in about a year ago. This project includes 2 laboratory suites at a college. The labs work with insects, so pressure cascades were absolutely critical. We need to make sure that insects couldn't escape. They had a very, very tight tolerance that needed to be adhered to. But one interesting thing we found when we started reviewing the documents was we had an occupied mode of operation and we had an unoccupied mode of operation. We had both suites. We had 2 separate suites. Each suite had a dedicated makeup air unit, 100% outside air. There were no VAVs. There were no air valves. This was a hard set balancing damper balance, and each unit had a VFD. They also shared a common lab exhaust. Again, no VAVs, no air valves. This was just a hard balance. There was also a independent exhaust fan feeding a existing fume hood, but that ran 100% of the time and didn't come into play with the occupancy. So again, no VAVs, no air valves, no modulation. So let's assume that the pressure cascade could be met with the occupied CFMs listed. We get everything balanced, set in place, locked, and everything's working. Now, what happens when we move to unoccupied mode? The lab was designed to go into unoccupied mode condition after hours to reduce energy. The intent was to strictly maintain those pressure cascade requirements in both modes of operation. While we reviewed the sequence, several issues became clear. We did. I want to point out we did have 2 motorized dampers that, in the unoccupied mode, would close off and eliminate general lab exhaust from 2 rooms. But when we start looking at the numbers, we saw that this was really going to have a problem. So again, no VAVs, no air valves. So if we look at MAU1, which serves 3 rooms, the unit ramps down to about 27%, of the occupied flow in the unoccupied mode. However, we have a range from 18% all the way up to 100% airflow maintained in each room. Without VABs, without air valves, that's just not going to happen. The same situation with MAU2, as we see, that one has actually more distribution and has quite a few different ranges. Exhaust fan, same deal. We had multiple rooms that were supposed to maintain the same airflow in both scenarios, yet adjacent spaces and even spaces that were connected to the same duct run had dramatically disproportionate drops. We brought this up in an RFI. We had multiple meetings and we went through this, and ultimately the unoccupied mode was abandoned, and we went with 100% occupancy because the unoccupied mode just wasn't practical for what the system that they were trying to install. The biggest reason we identified this so easily is that whenever a sequence is outlined, it's the responsibility of the tab contractor to figure out how to test it, how to verify it, and how to document it. It's our real world experience that drives our insight. Another example of design issues we see would be with life safety. In many markets, the tab contractor serves as a third-party testing agency for life safety systems. The International Mechanical Code states that smoke detectors are required in systems, quote, with a design capacity greater than 2,000 CFM. Now, there's a lot of other caveats, there's deviations, and there's other requirements, but this specifically is one that we run into quite a bit. The verbiage of greater than 2,000 CFM can really be a gray area when specifying whether or not a system requires a duct detector. We often see systems specified at 2,000 CFM design with a plus or minus 5% specification. The units are typically direct drive units with an external static pressure listed at 0.5. Issues arise when systems operate at a lower static loss than expected. The unit delivers 2030 CFM on low speed because we have an open plenum return and oversized ductwork to accommodate for sound. Now that system requires a duct detector, and we're in the 11th hour. We've seen duct detectors added to units late in the game and cause delays in turnover. These are potential issues we can help identify before the schedule is impacted. When we find these types of issues, whether it be the sequence previously talked about or with life safety, we need to get them documented and in for review ASAP. Again, identifying and solving problems as early as possible will save time, money, and headache down the road. In addition, this is when concerns and questions can be documented and addressed. If we find concerns and document and they're ignored, everyone's better protected by the fact that they were brought up and documented in the first place. So this brings us to the construction phase. Now, I like to break the construction phase up into two parts. We have the pre-startup portion of the construction phase. This is before power, before air, we're in there actually testing, right? This is our opportunity to verify installation, coordinate accessibility, and identify issues early. Typical activities include duct air leakage testing, hydrostatic witnessing, progress walks, and installation inspections. When we have post-startup, which we'll talk about in a moment. Let's start with the pre-startup. Too often I see tab teams come in with vague or no plan. They come in, roll out the plans, and just get going. This leaves the project outcome to chance. This pre-startup portion of construction is our opportunity to clarify priorities. What are key dates and milestones? When is power supposed to be coming on? When do we have started? Are they going for TCO? What are those drop dead dates that we need to incorporate into our tab plan and our tab schedule? We need to monitor progress. Site walk and accessibility reviews can save time, money, and energy later in the project. We also want to outline our processes, identify our predecessors who we're relying on for our scope of work, and coordinate with them. Collaborate with the commissioning team and the design team to help clarify expectations. How do they plan on validating the system? And how do we plan on testing and documenting the systems? This is the tab contractor's time to shine. If the contractor is thorough, many issues can be circumvented during this pre-startup portion. So what are we talking about? What are we looking at when we're talking about what kind of things to look for in the accessibility review and the site walks? Let's look at air first. So it's the tab contractor's responsibility to not only know how to use their equipment, but to know when and where to use that equipment for accurate testing of the systems. A bad measurement is much worse than no measurement at all. We need to make sure that we can provide accurate and repeatable readings. So look at this AMCA diagram. This outlines the effective duct length required for proper airflow development. So if we look at that, for proper airflow development, we need 2.5 duct diameters downstream of a fan for a system operating at 2,500 feet per minute. An additional duct diameter needs to be added for every added 1,000 feet per minute. This is just for proper development of stable airflow. Accurate measurements are another matter. Dwyer, along with other manufacturers, outline a requirement for 10 straight uninterrupted duct diameters for accurate use of their instruments. To put that in perspective, a 20-inch by 12-inch supply duct would require 175 inches or 14.5 feet of straight duct to perform a textbook traverse reading. Now, this is available about 0.003% of the time. It is up to us to identify testing limitations and potential issues. We need to outline how we can verify those or alternate means of testing. We don't want to have these debates at the end of the project during functional performance testing. We want to get those settled in advance. Now, air is a fluid and behaves like water through a distribution system. So with that said, how many square drops of water have you seen? And how many rectangular hoses have you seen being used? One key insight that the tab contractor can provide is the potential for inefficiencies and system effect. And yes, system effect is a real thing. Motors drive fans to produce work. That work is primarily expressed in two ways: pressure and velocity or flow. System effect is a description of the inefficient transitions and causes of turbulence and pressure loss through a system that result in underperformance of airflow. Sometimes this is due to one or two issues that can easily be found, but more often we find that this is death of 1,000 cuts. So take a look at this distribution system. This is an ERV system feeding outside air to 3 levels of living units. Very low flow, 50 CFM. What kind of pressure loss do you think we can expect from all of these transitions? Probably quite a bit. Well, let's look at the one behind it. It's even better. That one jogs over before it gets into the room. So when we think about all of these through, the 100 plus, taps like this running through 3 stories of the building, we can really see how added static pressure that's not accounted for can really start impacting the overall system. Here's a good one too. If you look close right there, we can zoom in and you'll see that transition. Now, what's interesting about this is that the air is going to run past that transition, hit that back wall, and then be forced backwards and then up to 90. Now, that's a huge pressure loss. And this is a low velocity, but we see this a lot of times on higher velocity systems on main ductwork, and the turbulence it creates just kills the performance. Another issue that we run into is perimeter versus area. Now, with electrical lines, controls, sprinklers, and the myriad of other contractors who have work above the ceiling, it's often that we have less space than we thought we would. So what happens is a lot of times the installing contractor is supposed to put in a 16-inch high by 20-inch wide duct, but only a 14-inch high duct would fit. So they make the executive decision to take 2 inches off the height and add 2 inches to the width. So let's see what that does to the perimeter. So we see we have 72-inch perimeter on the original ductwork, and the redesigned ductwork also has 72. Well, no harm, no foul, no change. But let's see if that translates to area. We have 320 square inches of free area in the design duct, but only 308 square inches in the adjusted duct. Now, this will increase the pressure requirement of the system to move the same amount of air. Additionally, if this decision is made in the field by the contractor, then they will inherit the cost and responsibility to rectify the situation if it won't work. These things need to be reviewed and submitted as RFIs. And these are something that, the tab contractor needs to kind of look and make sure that we don't have excessive changes. Now, what about hydronic systems? Let's look at some common hydronic issues. So we'll start with pumps. So this is a common pump curve, and pump curves are commonly used to verify pump performance. The chart references a pressure drop across the pump at a specific operating condition. Now, when we talk about pressure drop across the pump, we are specifically talking about pressure drop across the pump. We're not talking about a pressure drop prior to the strainer and at the check valve or triple duty valve. We're talking about directly in and out of the pump. If we need to make sure that we have these test ports or this gauge assembly installed in the right location, or our readings are not going to be reflective of the provided pump curve. Balance valves. This is an interesting one. So balance valves, we have test ports that we need to get access to, and typically we need about 3 inches of free space above these test ports. We need to make sure that insulation doesn't go over the entire assembly itself and leave us no access to find, let alone identify the what size the circuit setter is. We also want to make sure that we don't have control valve housings that are installed directly next to it with the housing covering the test ports. These are common issues that we want to get resolved before water's in the system and before ceilings are in place. It's much easier at this point than trying to deal with it 3 weeks before turnover. Another big one is air in the system. We need to make sure that the air has been bled out before we start balancing. And we also need to make sure that there's pathways for the air to get out. There needs to be an air bleed at all high points. Every time a water line goes up, over, and back down, we have the potential for an air trap. So we need to make sure as we're going through in our preliminary walks that the elevations are proper and we're not allowing for those airlocks to take place. Another one that's very rarely talked about is the orientation of shutoff valve blades. The orientation can dramatically affect the pressure loss to a system. This is especially important just before or after a transition or header connection. With the valve open, it needs to be oriented so that the flow of water moves past the blade like a shark fin through water. If it's oriented differently, then the water is forced to move up and over the lip and adds quite a bit of pressure. We've had some issues with headers coming off of right above a pump assembly and just killing the pump performance. And simply reorienting that valve had dramatic effects. In a full open position, the valve should have very minimal turbulence. So we need to collaborate with the commissioning team and help clarify expectations. We communicate our needs to our predecessors and to the construction team in general as we move into the balance portion of our scope. Again, verifying how everything's going to be validated, how we're going to test it, and that brings us to the meat and potatoes of the tab work scope. The post-startup construction process. At this point, the schedule has been pushed, the contractors start getting into their defensive positions, and the tab process should be well underway and issues should be coming to light. If the tab was actively engaged in earlier phases, issues should be minimal and manageable. If not, issues at this point can severely impact critical dates. So we need to be hands-on. This may be the point that the tab team is most engaged in the project. This is the lion's share of our work scope. Ironically, this is going to be the area that we spend the least amount of time covering today. We kind of assume that everyone understands the basic tab activities. With that said, we do want to concentrate on the documentation during this part of construction. No amount of planning can prevent every possible issue. This is why documentation is so important. We must record our progress, holdups, issues in real time. This needs to be distributed to the appropriate people and appropriate entities regularly. Because if it's not written, if it's not documented, it didn't happen. Now, everybody should repeat that and write that down and put it in a poster at their office. If it's not documented, it didn't happen. This is important because it's true for both issues and solutions. I've acted as a commissioning agent, as an owner's rep on multiple projects. And typically what we found is when there's issues or questions or ambiguity about a tab report or testing procedure, it's rarely due to subpar work or malicious intent. More often, it's a lack of documentation or clarification. We need to make sure we outline how we took our readings and why we took one approach rather than another, especially when we're kind of deviating from the norm. Now, this brings us to the acceptance phase. The base tab scope should be closing out, and we should be working on punch list items and fine-tuning the system at this point. We're also, though, going to be working very closely with the commissioning team to validate the system and complete functional performance testing. In this final stage of construction, we often find hidden issues and subtle limitations of the system or design. The insight of the tab contractor can often cut through some of the nuance of problems that may overwhelm the team at large. With our experience and depth of knowledge with not only system limitations, but the relationships and interactions with associated systems, the tab contractor may help resolve issues more effectively. So I want to look at another project we did. This was a pharmaceutical suite I worked on several years ago, and this was an interesting one. We were brought into this project late in the construction phase, so we were not given the opportunity to review the design or the sequence beforehand. Everything was pretty much built out and getting ready to be started. The balance for this lab was a daunting process, as their air valves were value engineered out and replaced with VAVs on returned exhaust and supply. With pressure cascades that were 5 rooms deep and tolerances of 2/100th of an inch water column, the VAVs were not ideal for stability. We got everything balanced. However, at the turnover and right the acceptance phase, we were not able to get the pressure cascades to work. During this acceptance phase, the cascades for this suite were redesigned and plans resubmitted no less than 6 times in a 7-week period. So this is the original cascade diagram. Let's look at the final. Now, we have a multitude of changes. This includes not only pressure ranges and tolerances and airflow, but also room relationship requirements. You can see that multiple rooms have had their cascade requirements eliminated altogether. After reviewing the classifications of the adjacent spaces, it was decided that they were actually not needed. Further, we had multiple rooms that had the relationships reversed. After a closer review, they found that they were wrong in the first place. So this was a very frustrating situation, but we were able to get it resolved. We ended up finally getting everything set up, but we did lock the VAVs in a fixed position, and they were ultimately used as a very expensive zone damper. So now we come to post-occupancy phase. As a facility is taken over by the end user and the system's released into a fully automatic and operation, there are still several ongoing needs for test and balance contractor in most cases. One of the most common is seasonal testing. Now, seasonal testing is pretty straightforward. If you're in the great state of Arizona, where I'm from, you're not doing a lot with boilers in the middle of August. And if you're on the East Coast, you're probably not doing a loaded test on a chiller and cooling tower in the middle of winter. So seasonal testing is our opportunity to come back in and do a final evaluation and test of specific systems with the appropriate load. Then we have the warranty. After the FANO tab report is submitted, the warranty period begins. The tab agency is still engaged in the project. We need to make sure that we're warranting our workmanship. But I do want to outline that this is a warranty on workmanship, not comfort. It's also not a warranty on design. I bring this up and get up on my soapbox because a lot of times there are holdups with the tab report and it's not accepted as a final document. A lot of times this is due to little idiosyncrasies that are still being worked on, design limitations, maybe even some rework on some systems. The narrative a lot of times in that scenario is that the job won't close out close out because tab won't finish their job. It's not a matter of tab won't finish their job. It's a lot of times that tab can't finish their job. This is why early documentation is so important. So I'll get off my soapbox for now. Now we have optimization. Just because a project or system meets minimum code requirements and contract documents does not mean that there's not room for improvement. Are there areas for improved efficiency? This is often an added scope that will coincide with ongoing commissioning. This is why building confidence and trust with design teams, commissioning teams, and the end user are so important. You want to be utilized, ongoing on these projects. Then we have supplemental and annual certifications. Now, even though a project comes to a conclusion, often there are opportunities for ongoing commissioning and tab scope. If this is a lab or a healthcare facility, do they need regular room certifications and hood certifications? Is this a clean room? Do they need pressure cascades certified every year, or sometimes more than that? If it's a facility with dust collection or tools, you may need to set airflow through the dust collection system or the acid exhaust as tools are moved and adjusted. Then we come to comfort balance. Now, the best design is the one that no one notices. The comfort and happiness of workers will affect the productivity. This is why this may be an added option that's outlined in the original contract documents, or it may just be a request by the end user. But fine-tuning noise, temperature, humidity, or even energy savings may be a high priority for the end user. So I hope that I've outlined the importance of utilizing tab throughout all phases of a project, through pre-design, design, construction, acceptance, and post-occupancy. With that said, I think we can open things up to questions. Sim?
Sorry, I was in mute. Thank you so much, Justin, for that. And we're open for questions. Everyone, just go ahead and drop your questions in using the Q&A button. For now, I do see one question by Andrew Day, and it says, as a CXP, a common response we hear from tab contractors is that design reviews and pre-tab job walks are not included in their scope of work. Is it your opinion that tasks such as these should be included as base scope items, which happen on all jobs, no matter what? With tab being the expert, we need their inputs earlier and more often.
Yeah, so that's actually a great question, and it's a problem that we run into a lot, and it really is driven by getting the lowest possible number from every contractor. So when we go through and we provide a proposal to do balance, we like to outline everything that we are going to provide: commissioning assistance, job walks, reviews. And what ends up happening is we get our numbers cut, and everybody wants the lowest possible number. So either we get priced out, or they specifically exclude that portion. This is why we really need to bring tab up higher up in the food chain, and tab should be working for the general contractor, in a lot of cases, or the owner. We've worked direct with engineering groups. There's some really great mechanical contractors, but a lot of times, they're really under the gun to get the lowest possible price. So unfortunately, some of those benefits get value engineered out.
Perfect. Thank you so much, Justin. While we are going to move on to the next questions, others, if you have any questions, please feel free to go ahead and drop it in using the Q&A button. Justin's here to answer your questions. So moving on to the next question, Justin, we're going to use one of the sample questions. This one is, what can we do about the installation issues if tab is contracted in the construction phase?
Okay. So this is another issue where we run into not getting involved in a project until the late stages of construction. And unfortunately, a lot of times we end up finding issues that have already been installed and now require rework. So the biggest thing I can say is when we get involved early, the earlier we can get involved in the project, the better. But as soon as we are involved in the project, we really need to do a thorough investigation as soon as we get on site. One thing we've seen with some contractors is they get on site, they run into one issue, and they write it up and they walk off and say, let us know when it's ready. When we come back, now that issue is resolved, but we pop the next ceiling tile and find another issue. So what we really encourage and a good tab contractors, they'll go through and really try to identify any issues as soon as they get there. We want to get those identified, documented, and under review as soon as possible, because a lot of times they do take time, and they will have added cost and added time to the schedule.
Interesting. Thank you so much, Justin. I see another question by Raymond, and he's asking, will there be any policies towards conflict of interest?
Conflict of interest. Well, as far as who we work for, I'm not sure what he's asking. What was that?
It just says, will there be any policies towards conflict of interest? So what I can do is, Raymond, if you can go ahead. Okay, so he says
Well,
for
I can answer
stops.
that.
Mm-hmm.
So the ABC, one of the founding policies of the ABC is independence. With that said, we do end up being hired by the mechanical contractors a lot of the time, and with a good contractor, that's typically not an issue. However, a lot of what the tab contractor does is verifying the mechanical installation, the controls, and so there is somewhat of a conflict of interest sometimes. It really comes down to the ethics of the companies. But again, that bringing tabs contract further up into the food chain is really that key. If we can get up with the general contractors, that kind of takes a lot of that conflict out.
Thank you so much, Justin. The next question is, if a project is not commissioned, when should tab be brought in?
So whether or not a job is being commissioned, tab really should be brought in as soon as possible. Whether it's being commissioned by a third party or not, the value added by having your tab team go through and find issues and verify things well in advance, it really transcends whether or not it's being a commissioned project. So I would always say, as early as possible, we like to get in during the design phase. If it is a existing facility, we really try pushing to get pre-reads and evaluations done before any final design decisions are made, because it's really hard to go back in later construction phases and resolve those issues.
Perfect. Thank you. And I see that we do not have any questions at the moment. So if anybody still has any questions, we have another 10 minutes to go with Justin. You can go ahead and drop your questions in, and Justin's gonna be able to take your questions then. Justin, while we wait for more questions to pop in, do you have any insights from any of your recent projects that you'd like to share with everybody?
One thing I do push, and we've had a lot of success with, is pre-tab checklists. We submit pre-tab checklists with our submittals, and we like to, whether it's a commission project or not, a lot of times with a commission project, a tab plan is actually specified. So we include that in the tab plan. And that really gives everybody an outline of what we're looking for and what we're going to need. A lot of times tab is looked at as a task. So the construction team looks at it as, you know, a task that needs to be put on the schedule. They put us in a block and they say, okay, here you go. Here's your, you know, you have a week. What's typically not understood is tab is a process, just like commissioning. And we're reliant on a lot of predecessors and a lot of different contractors coming together and giving us a functional system to test. So providing pre-tab checklists and being very engaged with job walks and getting and verifying, that's gonna save a lot of heartache later. And touching back on the first question, you know, multiple job walks aren't necessarily something that's a part of the tab scope. With that said, it's advantageous for the tab contractor to spend time and do some work, get out there and verify beforehand and make sure that things are ready for them. If they're walking out expecting to have the red carpet rolled out, they're going to be disappointed.
Thank you so much, Justin. And I think there's another question that's just popped in. It says, what is your opinion on recalibration of VAVs? Should it be part of the tab scope?
Well, recalibrate. So I'm assuming we're talking about existing facilities. So obviously a new building, we're going to do our calibration of the VAVs. We do get situations where we have existing VAVs feeding a couple pieces of distribution in the workspace, and there's no call to do any work on that VAV. And we really like touching base with the design team and outlining the importance of making sure that we don't want to assume that that VAV is calibrated. We don't want to assume that the right set points are in there. We should be incorporating recalibration of any VAVs that we work on into that. And then ongoing, over the years, calibration on VAVs will drift. So every couple few years, we really should be re-verifying facilities, and we encourage the facilities we work with to kind of spot check here and there, and we'll verify that everything's staying calibrated. And if it's not, we'll go through and recalibrate. It typically saves a lot of energy.
Interesting. Thank you, Justin. I see another question that's by Drew, and Drew's asking, can you touch on the topic of tab for domestic HW recirc systems, often missed in specs and plan, need for instrument disinfection, etc.?
Yes. So yeah, a lot of companies have a dedicated set of equipment for those systems, which that's the right practice, is to have a dedicated system, because you can get them clean, but it is it needs to be documented, it needs to be thorough. A lot of times those systems are shown on the plumbing plans. They're not specifically outlined on the mechanical plans. And unfortunately, a lot of times the mechanical plans are the only things provided to the tab contractor when they're doing their initial proposal. So, you know, we really encouraged kind of digging in, making sure that we have all the contract documents so we can do a thorough review. You know, usually it alludes to it in the specs, and you know, you kind of know whether it's there or not once you have some experience, but it does slip through the cracks. And the big thing there is really making sure that the tab scope is reviewed. That's another big one. The tab scope should be reviewed by the team. You know, a tab scope that just says balance work this much money is really vague. We want a tab scope that outlines, you know, this is what we're doing in hydronics, this is what we're doing for air, we're doing specialty systems, CO2 testing. We want to make sure that all those components are specifically outlined and they're not excluded, or just a blanket statement saying if it's not in here, it's not included.
Perfect. Thank you, Justin. And I think that's about it for today. I do not see any more questions in. So I'm just going to ask you to, Justin, do you mind? Yeah, thank you so much, Justin. Well, again, that's a wrap for today's webinar. Thank you, Justin, again, for a great presentation and a good discussion. And thanks again to our sponsor, Evergreen Telemetry. Last but not the least, thank you all for joining us today. Before we wrap up, I'd like to remind those who haven't already to take a look at our upcoming Tab and CX seminar at CX Energy 2024 in San Diego on April 30th, which is sponsored by Ameritech and is only 2 weeks away. So we have 6 presentations lined up, delivered by 10 industry experts covering topics such as mechanical plans, fume hood standard updates, air handling systems, healthcare, airflow design, and much more. So be sure to visit abc.com for further details. And until our next webinar, stay well, and thank you for your valuable time. Again, thank you so much, Justin.
Thank you. Thank you, sir.